I need to talk to you about the error function. So let's say that this is my my order function. I don't know why they call it order function, but let's say this is h to the n power, and h is my step. This is for Euler's. Then c times h to the n with a h less than 1 is the upper bound for the error. Okay, so what does this mean? The local truncation error only takes into account the error of one step, assuming the previous step in an iterative process is correct. Error of a single step. And so we can write it as this. The global truncation error, on the other hand, is the overall error. And the overall error is O times h to the n power right here. So it's 1n less. So if you consider that this is less than 1, then the local truncation is less than the global truncation, which is what you would expect. So for Euler's method, the local is the function h squared, and the global is the function h, so one less than that. The improved Euler's error, for the improved Euler's error, we have something else. We have the local is OH3, and the global is OH2. So let's quickly look at an example of how to do this. Say your H is equal to 0.25. For Euler's method, your local error would be O of 0. Would be what? O of H2 we have right here. So for local error for Euler's method, we have this, which would be less than or equal to C times 0.25 squared. Now my global error would be OH3, which is less than or equal to C times 0.25 to the third. And then my local error for Euler's method, what's going to be OH, not squared, h to the third now, see? Remember that? That's going to be less than or equal to C times 0.25 to the third. And for this, 0.25 squared. And so this is how you find your local error and global error. There's going to be some questions on the quiz 5, and we'll go over them real quick. And the book from which I'm supposed to learn this says that it's not the scope of the book. So I'll have to dig into how to find this or how to understand this better. See you next time.